Today I want to use the Desmos calculator, and I want to do probably one of the harder problems in your homework set for 2.3, and that is problem number 65, the one having to do with the fish swimming. We want to find the minimum speed that the fish will swim so that they exert the least amount of energy as they swim against a 5-mile-an-hour current. If you can imagine a similar thing, you being on a treadmill, and the treadmill is going 5 miles an hour. Let's suppose the treadmill is going 1 mile an hour, and you want to do the minimum amount of work to overcome that 1 mile an hour. You're not going to race. Well, you're going to race right off the treadmill, but anyway, there's a minimum amount of work that you're naturally going to know. Same with the fish. And the biologists have come up with an equation, and we're going to enter that into Desmos right now. I tap on that screen there, and the equation is 2.73. I don't have a v, but I do have an x. I'm going to cube it. Then I'm going to multiply this, and this is where it's just so good for you to practice with Desmos, by 10 divided by x minus 5. And I'm going to close my parentheses. And that is the equation that they give you in the book in problem 65. And what we need to do is find a minimum for this equation. I'm going to go back to the origin, and you can see as I widen it out that I have what looks like a cubic, but I'm going to put in the corner because I can't point. There's the x coordinate 5 on the x-axis, and if you look, this line never crosses 5. We're looking for a local minimum. It doesn't look like we have one, but we do. We just have to really zoom out. There at 4600, I find the other part of the graph that deals with numbers greater than 5, and there is my local minimum. With Desmos, you just tap on the point, tap again, and it will give you the coordinates. We're not interested in the 4606 number. That's just merely what the graph is telling us is the height at that point. What we're interested in is that x-coordinate. That's the value, that's the speed that the fish swims to exert the least amount of energy, 7.5 miles an hour, going up against a 5-mile-an-hour current.